everyone. Once again, hi everyone. Junior, we can see your face. Yeah, it's all right to on your camera. I wasn't saying you shouldn't. Uh, from yesterday, we were able to, you know, talk about introduction to Rust. And from yesterday, we were able to install the Rust dependency, what was needed to run Rust in your environment. We also were able to install VS Code, which will serve as our code editor for the Rust program. And also, it will serve as your code editor. You can use VS Code for different languages. It's literally an editor. So you can use it for different, languages. So today, we would continue from where we stop. I want to be sure that every single person on this call has already completed the installation of both Rust and VS Code. Are there anyone in our midst that have not been able to do that so far? Then, why have they not been able to install VS Code and Rust?
How are you? I couldn't find time yesterday after the class was finished, and I couldn't tell you. You see, so since yesterday I haven't done that horse, but that other one I did download.
Okay, great. So, while this class is going on, I would advise you to start downloading it. Okay. What about Joycey? Why were you unable to download?
Hello, teacher. I've not had Wi-Fi.
Okay.
Yes, I'll download it once it's back.
Okay. Great. Okay. So, based on the reasons I can see here, it means everyone that have not been able to download and install it, it's basically due to personal issue, not because they don't know how to download and install it. Okay, I guess we are good to go. Now, there's a question in the chat that says, how can we check that Rust has been installed on Windows?
I don't know how to do it.
What?
I don't know how to download it. The Rust.
Are you serious with me right now? I thought we already explained it. We shared your screen now.
Like I said, the last time you were showing someone, but the time was finished, so I couldn't also ask for help, and we went on late yesterday, remember?
Okay, no problem with that. There's no problem. Today's class is not based on downloading and installing Rust. So after the class is over, you can stay behind and I would help you out with that. So we don't use the times class for that.
Okay. Thank you.
Yes. So any other person that has not been able to download and don't know what to do, but if you know what to do, you can start downloading already now based on what you've learned from yesterday's class, and so you can follow along. So having that in mind, I would share my screen and we would basically continue from where we stopped yesterday. So I'll share my entire screen. I hope everyone can see my screen. And then get a thumbs up if everyone can see my screen. Maybe it's clear. Okay. Okay, great. Thanks. Okay. So we've been able to install Rust, and then I started talking about let me go back to the chat. Oh, I didn't answer that question. Oh, okay. Okay, I guess someone has answered the question then. But if you use Rust -- version, it won't show you Would it? It won't show you. What you would use is Rust C dash version. Would Rust C even show you? Yeah. So Rust C is what you will use, not Rust. For the person that answered this person here. So it's not Rust dash version, it's Rust C. Okay. So let's go back and continue. So now I'm talking about our introduction to today's class. We were meant to start with talking about functions, variables, control flows. So we would use this to explain what a function is. We use it to explain what a variable is. We use it to explain what a value is. So now let's start. Now, this fn is the keyword for function. Now, this main is the name of the function. Now, this parenthesis is what comes after the name of the function. And inside of the parenthesis, you can literally have what we call arguments. Now, in this case, you can't have argument inside of this main due to a reason which I'll be explaining later on. But have it in the back of your mind that this is now what the structure of a function is. So I'm going to create another function. Let's say function, let's name it function. Now, function is a function. Can you see? Now, what is this function? It has the keyword fn, which is the keyword for function, and it also has function. This function is the name of the function. The name of this function could also be a string name. This could also be the name of the function, as you can see. So what comes after the fn keyword is a name, and what comes after it is what we call parentheses, and after that is what we call curly braces. Now, inside of this parentheses, I mentioned that you could have what? You could have arguments. Now, before we move on to what arguments are, I'm going to go back to what variables are. Now, let's name this hello. Function hello. No, I like smaller letter. Yeah. So let's name it function hello. Now, what is a variable? A variable is literally a container that can hold a value. Now, what is a value? A value can come in any form. A value could be a number, which in this case could be an integer or an unsigned integer. A value could also be a string. A value could also be a Boolean. What is a Boolean? True or false. A value could also be a character. So now, how then do we declare a variable? We declare a variable by using the keyword let. And now in this keyword, you have the name of the variable. The name of the variable could be name. Let's say the name of the variable is name. And then you can now write a string word. Now, this word is not a string. It's a string slice. Now, how do you create a string? You create a string by saying string from. So now, this is a string. Notice that it actually showed the data type in front of it. Now, in this case, this let is the keyword for creating a variable. Now, this name in this case is the variable name. Now, this string from word. In this case, word is the value. So this word is kept inside of name. That is a variable. Does that make sense? Now, let's move on. Let's call another type of variable. In this case, let's use a number. Now, you notice me saying number, and I explained earlier that number could be either an integer or an unsigned integer. In this case, let's use an unsigned integer, or anyone. Let's just create a number. So let's name it num. So let's say our number is 10. In this case, you notice that you have something in front of it that shows I32. That is integer with 32 bytes. What does that mean? I'm going to talk about what it means in coming class. But I just want to explain what a variable and a value is. So for every new variable that you create, now this time we want to create a Boolean variable. This could be true. This is a what? A Boolean variable. Notice at the front that you have the type of variable it is. That is because Rust compiles the code at compile time. What does compile time means? If you can remember from previous class, I explained that as you are typing the code, it is compiling the code. That is what compile time means. So now we have name, which is a string. We have num, which is an integer. We have married, which is a Boolean. So now, for all of these things that I've made mention of, all of them are variables that you can create. Now, notice that when I was creating these first variables, first of all, I was just writing the keywordlet, and then the name of the variable equals the value that I'm placing inside of the variable. But then, notice what I am about to do. So I'm going to say name. I'm going to put column in front, and I say string, and then I say string from, and I add word. Now, notice in this case that the name I created here, I added string in front of it. The string is to identify the data type for that particular variable. So the data type for word here is a string. So if you notice the one I first created here, let me name this name 1. Now name this name so they don't clash. So for this first one, notice that automatically I didn't write this in front of it, but it was able to detect it, that it's a string. Now, in some cases, when you are writing some kind of compound data type, which we'll be moving on to and talking about, it will be needed for you to specify the type of data it is. What do I mean by type of data in this case? It will mean that you have to specify the type of variable it is, the variable type, whether it's a string, an integer, an unsigned integer, a Boolean, a character, that's a char, a string slice, or whatever it is. You have to definitely specify it. Now, before I move on, is there anyone that doesn't understand what variable is at this point, based on what I've just explained? You can use the raise hand button. Okay, Junior, what's your question, please? You can unmute and speak. Okay. Larry, what's your question, please?
I'm lost from...
Okay, wait, Larry, let's hear from Junior, please.
I still don't understand the variable so clearly. If you could clarify, please.
Okay, great. I will do that. Where of Larry?
Thank you so much, Ayo. And apologies, I'm only able to make your class on Wednesdays and Tuesdays every other 2 weeks because I've got a clash in classes that I also attend during these days. But mine is a small thing. I'm just curious. I've noticed that on the string you added the is it semicolon notation? I just wanted to know why the semicolon notation. I'm just curious.
Okay, yeah, at the back, at the end. Oh, the semicolon literally to ensure that this is completed. So this line of code is completed. That's what it is.
All right, check. No. There's you've got a string equals string. Is that full colon? I'm sorry, maybe.
Okay, you mean this one, string column from?
Yes.
Okay, you don't have to worry about that now. Yes, as time goes on, you learn about, although I just want you to know how to create a string for now. But as time goes on, you learn how to create a struct that then implements methods. This is literally a struct string, and it implements one of the methods, which is functions that it implements is from. Notice that when I created, let's say name2 is equal to word, I could have just done this, right? Well, notice that this particular word is a different data type from this one. This is a string, while this is a string slice. What's the difference between a string and a string slice? We're going to talk about that when we are talking about dynamic data types. When we are talking about data types that are kept on the stack and data types that are kept on the heap. We are still going to talk about that. No worries. All I wanted everyone to understand at this point is understanding how a variable is declared. So is that gotten, Larry?
Yeah, thank you so much. Good.
And also for the classes you are missing, you could probably watch the videos. All these videos are recorded and they are being sent to YouTube. It's uploaded to YouTube and it's basically arranged in a Notion page where you can easily access them. So you can get that. Going back to understanding to Junior's question. Okay. Yes, you would get the link. Don't worry. Let's not distract the class with that for now. You'll get the link. Anyone in the class that is with the link can just share it now. That's the link to the Notion. But if not, I would share that after the class. Now, Junior, to explain what a variable is and what it is to a value, I'm going to use the example of a bucket. Now, a bucket, you can use a bucket to take water. You can also use a bucket to carry firewood. You can at the same time use a bucket to, carry something else, to carry milk. It could be used to carry fuel, but it's more like a container that can carry something. So these variables, you can see them as containers that carry something. Now, these containers can now carry what we call values. All of these things we created, they are what we call values. So these values now have different data types. So this container, just like it is carrying firewood, that is carrying water, that is carrying milk, carrying fuel, all of these are different data types that individual values are. So you can see this variable as that container that is carrying it. Does that make sense to you, Junior? Is Junior on this call?
Yes, yes, yes. I was unmuting. Yeah.
Okay, great. Now, how do we know that these containers are really carrying all of this? I'm going to comment this. I'm going to literally comment everything here. And I'm going to run what we add here, println hello world. So I'm going to run that here, and it's just to show how to run your code in Rust. So I'm going to do cargo run. Oh, it's going to compile it, and notice what did it do? It printed hello world. So it printed this. Now, in exchange to this hello world, we want to try to see if we can actually print this word from here. So I'm going to uncomment it. I'm going to bring this down, and I'm going to remove word from here, and I'm going to substitute it with something else, and I'm going to say name. I'm going to do this, and I'm going to try to print it. Did you notice that we still have hello world? Notice that this container is carrying the word, and then I added the word here, and then I can literally print it out. So this printing is actually a macro that you use to print out to the console. So as we are working, we want to see what we are working on. You can basically use it to debug and ensure that your code is doing what you want it to do. You understand? So we're going to be using it a lot. So as you can see, this name carrying this particular variable, particular value, that's word, is being printed here because it is used. So it's going to it's just like the bucket holding that water. You now need the water inside of it. So if you turn it over, it's the water you are going to get. You can do the same thing with every other variable that we have created. Imagine this variable we created, variable num. We can add I am number whatever is there. And what do we have here? We have 10. So beside name, we just add num. So you can go run. So you see, can you see hello world and I number 10? Can you see? Exactly. So this num is 10. The value there is 10. And so we are able to cargo run it here. So I noticed there's a hand raised up. Okay, Tess?
Yes, I just wanted to know, does the order of the operation of execution of code matter? So that print in, does it matter whether you put it where you put it in the code, and how does it execute?
Okay, so that's a very great question. So the code executes line by line. So I'm going to put this up, and we are going to experiment it, and you are going to see what happens. You notice that this name and number is now throwing an error, as you can see. Why? Because I'm going to use the idea of JavaScript to explain this. Now, there's something called hoisting in JavaScript for those that are familiar with it. It's the ability for you to declare a variable before you use that variable. You get hoisting is not allowed here in this case. So all these lines of code are being run line by line. So that means that you have to declare a variable before you use it. So if you declare this in a line before you use it, then it cannot find it. Look at it, cannot find value name in this scope. So it can basically not find it, cannot find value num. And so for this reason, I had to bring it down. And when I saved it, it can now find it because it has been declared. So the code is run from line by line, as you can see. So great question, Tess. Great question. So going back to our slide, we've discussed what a function is. We've also mentioned that the println is literally a macro. Now, variables and mutability. What is mutability? Now, when we talk about mutability, it goes on to talk about, in fact, it's one of the beautiful things about trust. A variable that is created that is not mutable cannot be muted. What does this mean? This means that you cannot convert a variable to something else when it is not mutable. What are we trying to say? Let's go back to our code. Let's comment all of this. Let's just create, let's number equals 12. Now we've created 12. Oh, did I create minus 12? Now let's just create 12. Now, in this case, we could say num equals 14. But then we have what we call a compiler error. Why do we have this compiler error? That is because this num is not mutable. So you can change a variable. You can pour out, like the illustration of the buckets we are using, the container you are using. You could pour out what is inside that container away and then put something else inside that container. But if you don't make that container a mutable container, then it is impossible for you to pour it out and pour something in. And that is the same in this case. So how do we make a variable mutable? We make a variable mutable by using the mute keyword. And now if we save this, this means that this variable is now mutable. Can we see? So why are we having something like an underline? It's saying that the value assigned to num is never read and then it is being overwritten. So what does this mean? This means that whenever you rewrite a variable and then you assign that variable to a new value, that means that the previous value that the variable is holding, it's going to drop it and then it will then have the new value. Now in this case, we did not consume this variable before we dropped it. So we had more like a compiler warning that, hey, you didn't use this variable before you in fact dropped it. That's one of the beautiful things about Rust. While you are writing your code, you are seeing your errors. Just like when I didn't add mute to this, I was already seeing a compiler error here telling me, in fact, the compiler error will tell me, it said, where is it? Cannot mutate immutable variable. So a variable that doesn't have the keyword mute is an immutable variable. You cannot mutate it until you add this mute keyword to it. Now, so many questions might now be popping up. Why would I want to add mutes? Or why would I want a variable to be mutable? Why would I want a variable to not be mutable? As time goes on, when you start seeing the application of this, you would understand that in some instances, you would want your variable to keep holding that specific value, and you would not want it to be reassigned. And in this case, it's more like a safety for your variable to not be reassigned. Okay, I think there's a message in the chat. I just joined. There was a blackout, so I could not join. I know what we are doing. Oh, so we continued from where we stopped yesterday, and we started talking about functions and variable. Now we'll be able to talk about what a function looks like. Then moving on, we spoke about variables, and we talked about different data types. We spoke about string, integers, booleans, and then we moved on to talking about mutable variables and immutable variables. And that's literally where we have stopped right now. So going back to our slide. Is it possible to reuse a variable? Yes, it is. Why? This is because as this variable is holding 12, What we did here, we overwrite the value that was here. But instead of overwriting the value that was here, another thing we could do was to increase the value or to mutate this value. Now, I'm going to try to mutate this value by saying num equals num plus 14. Can someone tell me why I'm having this error, why I'm unable to add to this value? Is there anyone that was willing to answer that question based on what we have been discussing now? Anyone? Yeah, please, Yuvan.
I guess the mutate function have been badly addressed.
Sorry, I didn't get that.
I guess the mutate function have been badly addressed.
Good. We didn't add the mute keyword, basically. We didn't add the mute keyword. So now, I'm going to now differentiate what we have just done. What's the difference between these, and the difference between can someone explain to me the difference between this, and this? Line 14, line 16, and line 18. Yeah, Edwin, please. No, not Edwin. Beulah. I haven't heard Beulah's voice in a while.
Okay, good evening, everyone.
Yeah, good
By the
evening.
way, I could not join yesterday because there was blackout in my own area. So like from line 14, number plus 4 is like saying 12 plus 4. Then you can, I think for line 16, the 14 is now being replaced to 20. Can you hear me?
Yeah, I can hear you. I can hear you.
Okay.
Okay,
Then
you know
for
what?
line 18,
For your answer,
yeah.
why don't you tell me the value of norm at line 14, 16, and 18?
Okay, for line 14. For line 14, we would have 12 plus 4 to give us 12 plus 14, that's 26.
Mm-hmm.
Then for 16, 20. Then for 18, you'll be adding everything and it's equals to 23. I'm not sure. Maybe I think maybe no. So I think this time around it may go for 20 plus equals to 20. I'm not sure of like the last one. I'm not sure of the last one at all.
Okay. That was an excellent answer. But let's have Larry give the answer.
Or am I giving the answer for the last one? Because I think she got both the first and the second.
Yes, you are very correct. She got
Yeah.
everything actually, but I just want to hear from you.
All right. The last one, the value for the variable for num, or the value for num, is going to be 12, isn't it? Because this is syntactic sugar. So this one is the number 12 is the num plus 23. So the total sum of it is going to be, is it 35? Should be.
Thank you for your answer. But does everyone agree with that? Okay. Adrian, please.
Am I giving the answer of num or am I explaining the whole thing?
Anyone, feel free to express yourself.
So the answer of the final answer of num is supposed to be 43.
Why?
Because
43 and not
according to what
32?
you've been saying, at first, on line 12, you explained that the mute the mute keyword is supposed to like allow the number, the variable number, in case it has been assigned a new number. Now on the next line, I think line 14, we are seeing that num is being assigned to num plus 14. So here we are considering the previous num, which was 12 plus 14. So that like the compiler is going to read this line as 12 plus 14 outputting 26. Then we go ahead and assign num a new number, which is 20. So meaning we are going to ignore the previous line because we have reassigned num a new number 20. So at this point we have our num as 20. So if we go ahead on the last line, line 18, num is going to be reassigned to the previous num plus 23. I am assuming that everyone understands the plus equals. Anyway, it means that we are adding the previous num to the new number that we are assigning it to. So we are adding 20 to 23 to get 43. That's the final num. Thank you.
Excellent. Okay. I think the other one has something for us too. That was excellent too, Adrian. You can unmute and speak, please. Okay, am I the only one that can't hear him? And every other person hear the other one?
Can you hear me?
Okay, yeah, we can hear you now.
Okay. I think she got the answer. I just want to explain that part that plus is equal to, because it's as good as like a num is equal to like num plus 23, which, you know, like a kind of, should I say, not writing in full, you know, as programming concerned, but she got it right, you know, it's like number, it's the same number plus 23.
Thank you very much. Thank you very much. Thank you very much. I'm actually I feel every other person should come and be the teacher because everybody is literally saying the correct answer. So I thank you so much for the answers. That was excellent. That was excellent. And true to it, if we actually print out what we have here, definitely, let's run it. Can you see? Num is 43. That's because at this particular point, num has overshadowed every other thing that must have happened here. And now at this particular point, it is now adding it to 23 here. And so it will then be what? 43. But let's assume we brought this up and we printed num here. What would num be? It would be 20, as you can see. So this is why it's important that when you're writing your code, you understand when you need to make your variable mutable and when you need to make it immutable. And this is a very beautiful thing in ROS because it actually creates safety. So it's not easy for your code to be muted by probably an external factor when it is not meant to be muted. So moving on, thank you very much everyone for that. Data type. So we have different data types. We have single values and grouped multiple values. What are single values? Well, single values are what we have made example of. For example, this is a single value. This is a single value. This is a single value. All we have made mention of are single values. Why? That is because this particular variable is holding in, let me point to this one I've not commented. This particular variable is only just one value. Notice, it's not holding a compound value. Now, what are multiple values? A compound type whereby you have more than one value. Now, a compound type could come in different cases. Now, before... let me not go to explaining it first. Let me just take it one by one. Okay, so a compound type could come in different cases. I'll say it so you can just, have it in your mind as we proceed. It could be a tuple, it could be a struct, And it could in fact be, now a struct could even be divided into a tuple struct. So you could form different types of compound. It's more like you compounding different data types. It could be the same data types, but you are now creating it in a way whereby you can have more than one data type or more than one value together as a group. We are going to see what that looks like, but we want to have at the back of our mind that we have scalar types and the compound types. So now, what are the scalar types? Scalar types, example I've made mention of is the integer, the floating point, the Boolean, and character. Does anybody know the difference between integer and floating point? It's a quick question. It's just to pick ahead. It's a simple question. Yeah. Was it Beulah? Okay, Larry.
Let me give it a try. I think here the integer would be a whole number. Then your floating point would be a decimal, isn't it?
Perfect answer. That's it. So your floating point is literally decimals. So notice I have literally been using integers since morning. But what if I add 0.7 here? What then does this become? It becomes a floating number. But why am I having this compile type? This compile error. Why am I having this compile error? Is there anyone that can tell me? Notice that we said Rust is always showing you your problem immediately. That is at compile time. As you are writing your code, if you are writing rubbish, Rust will let you know. Okay, we have Kibet. Please tell us.
Yes, thank you. It's bringing the error because since Rust is statically typed and you have defined num to have the I32 integer, it's there's a type mismatch between the definition and the decimal.
Thank you very much. Thank you very much. Excellent answer. So what that means is that even though we said a bucket that is carrying water can also carry firewood or fuel, the moment you carry that bucket and you pour water inside, Kibet, please, could you mute your mic? The moment you carry the bucket and you pour water inside, that means that bucket must always carry water. So even if you are pouring water out of it, whatever you are putting inside it must be water. That is all this is trying to say. So even though you can reassign variables, because Rust is a statically typed language, you can only reassign the same data type. So that means if I create a new data type, let me change this and remove it so we don't get to see the error. So let's say I create another data type and I name it, let's num floats equals 20.26. At this particular time, I'm going to keep adding the data type in front of it. So let's use F32. So I'm adding the data type in front of it. So in this case, we have a floating number. So the same situation applies to it. For this particular one, let me just add the mute. So I can say we can reassign this one to num float. Okay. Float equals 20 point something. So we can reassign any data type. But the most important thing is that whatever we are reassigning, it definitely has to be that particular data type. So that's the point from that. So let's go back to our slide. So in the scalar type, we have the integers, we have the floating point, we have the Boolean, we have the char. The char most times are used for Unicode. And when you talk about Unicode, sometimes you start talking about what we call regex action. It's okay. And what is this used for? As time goes on, you get to know about it. I don't want to deep dive into what we would not complete talking about. So all of these are what we call the scalar types. Okay, Kibet.
I have a question.
Yeah, please.
When you want to do addition and you want to do it in your function and you do it between an integer and a floating point, can that work?
That is a beautiful question. Is there someone from the audience that can answer that question for us? Beulah, please.
Okay, I don't think it will work. I think for it to work, I don't know, I'm not sure, but I think we would have to convert maybe one of them, the data type to that data type. Maybe you put float in front of it or num in front of it, so it will be the same thing or something like that. But I think it's
Very correct.
probably or most likely with flag and error.
Very correct. That's very correct. I'm happy everyone is participating. In fact, that's my plan. She's very correct with that. Now, this is because, for example, what you are trying to say is we are trying to create an addition, an arithmetics. Let's say, let me use what we have here initially. Let's use num and num floats. Let's say we have these two. We have add equals num plus num float. Now, in this case, we are going to have problem. Why? This is because we are adding a float to an integer. Why? Because at the end of the day, the first thing we always want to do here is to add the data type. Remember, so this particular place, we need to add the data type, whether it's a float or it's an integer. Now, when we now say this is a float, or we say this is an integer, and then we end up adding something that is different, then a problem arises at that point. So in that case, just like Edwin mentioned, Beulah mentioned, you have to convert it. In this case, you can convert it by saying as I32. And in this case, what it does is it will convert this one into an integer. Or if you are willing to make this one the float F32, then if I save this, you notice that we have a compiler error. That's because both of them are now at this particular point I32. So in this case, you can just change this one to as what? As F32, and then remove this from here. And then once you save, your compiler error is gone. So that's for that. So moving on, we say we have Boolean char. So for integer types, I've made example of the integer types. But what I'm about to ask now is a question that would probably be for some that have background in computer science. But then notice that from our slide here, we said we have I8, U8, I16, U16, I32, U32, I64, even up to I128. Can someone explain to me the differences between this I8, I16? Now, I'm not asking you to explain the difference between I8 and U8, but rather the difference between I8 and I16 and I32. Okay, Beulah, please.
I'm not sure, but I'll try. I think for each of them, for we have for 1 8 bits makes a byte, something like that. So like the bytes is like 8 for every 1 bit. You would get like when you get to add like 8 times 8 of it, that's 256, and you get to have 1 byte of that. So I guess so for every like there's 8 bits, there's 16, there's 32, there's 64. So it depends on whichever one that um I think that's what I can still say about that. Sha. I'm not sure
Yes,
about
yes, but no. Yes and no. Okay, so let's hear someone. Let's hear Tess now, please.
Yes, I think it's just the size of the number. So 8 would be a number, whole number that is 8 figures long, 16, 16, 32, and so on up to 128.
That's not exactly it, but thank you very much. Thank you very much for trying. Let's hear from Biodun, please.
Okay, so for me, I think it's more of when you are writing code. I don't want to go into the technical jargon, but more of in some is more of efficiency. Like speed. If I'm more of if I'm writing code now for speed's sake, I want to run fast, in terms of compiling, and I want my the times to load and everything, the time of the speed, to the efficiency of it. Then I can be thinking of maybe the 32, the 8 or stuff like that. The i8, yes, the i8 against maybe i32, or i32 against i64, stuff like that. So, but in summary, it's more of when you are thinking of memory, when memory is constrained, as regards your programming against, thinking of large number, the larger number, which is have to do with the i16, i64, i28. So, in summary, it's more of, are you like in economics, they say opportunity cost. Which one do you want to go for? Is it of memory efficiency and the speed, or you are thinking of, you want to get the accurate answer? Like if I'm writing code now that has to do with financial stuff, that has to do with money matter, that I won't think of this. Yes, the speed is matter, but accuracy, I want those things. Is the precision, is very key for me. Why writing something that maybe I'm writing code that has to do with for bank, maybe for like maybe like newsletter organization. I'm thinking of speed, like at the fingertips, memory constraint, memory efficiency for me. That's what I would just say.
Thank you very much for the answer. So Biodun was able to help us understand the importance and the use of having those different integer size. Now, he pointed out some things that are very, very, very correct. The memory, understanding the memory size, which Beulah actually explained too, that it's more like the bits, which is the memory size. But then we have still not gotten that answer. Why Biodun broke everything down to the use, he didn't touch on what exactly each one of it contains. So let's hear Edrin, please.
My answer is brief. Me, I think the I8, I16 is basically indicating the machine, like, okay, like, let me say I have a 64-bit machine, 32-bit machine. So when you declare an integer, you have to declare it basing on that, what do they call it? The type, okay, like the size of your machine. Like for people who have 64, who are running a 64-bit machine, they use i32. Those that are using a 64-bit machine would use i.
Thank you for your answer. Thank you for your answer. Yes, you're talking about the memory, still talking about the memory, but no one has made mention. Please, let's hear from Larry. No one has made mention of what they exactly are.
All right, let me give it a try, Ayo. So you have got about 4 billion allocations to your memory. So if you want to use big numbers that will require more, you might have to specify, I guess. So especially Rust gives you this opportunity to specify whether you are crossing over into big numbers, you require a larger chunk of memory. So especially with the memory, what's the right word? The memory restrictions that we have, I think not sure which byte size that is, whether it's 64, 128, somewhere there. But you have the initial allocation of 4 billion. Then other programming languages, basically like Rust, and then, they give you an opportunity. I think JavaScript gives you an opportunity to have more than 4 billion. So those allocations give you the opportunity to do that. Obviously, I think the 8 gives you the opportunity to work on the level of chars. So if you're working on the level of chars, I guess you can use the 8. Yeah, I'll end there.
Thank you so much. Thank you so much. We took so much time on answering this, but I really appreciate everyone, because from Beulah to Biodun to Larry, Edrin, every single person are actually correct in their own sense. Because one thing everybody majorly spoke about is memory. So everyone was able to point out that this is literally pointing to the memory size. And in all honesty, that is the truth. Now, Biodun now specifically went on to talk about how important specifying a particular memory is, while Larry also went on to talk about the memory size required for certain particular integer size. But one thing Beulah said that I appreciated from the beginning is mentioning bits. Now, here's the calculation for it. Now, looking back, what I'm about to do is just a pure computer science knowledge that you just, as someone writing code, should just have. Now, for what you have here, I8, it means it contains 8 bits. Now, what does 8 bits mean? 8 bits literally is these 8 bits is equal to 8 raised to 2 raised to power 8 minus 1. This is what 8 bits means. So that means that 8 bit memory size can only contain 2 raised to power 8 minus 1. And 2 raised to power 8 minus 1 is equal to 255. The same thing applies on and on and on. For 16 bits, 16 bits is 2 raised to power 16 minus 1. So what are we trying to say? If you create a variable and you say this variable, let's name it, I like using num. So let's just say num3. And now in num3, we said num3 is I8. What this means is that num3, the variable size, which means the memory size, the maximum memory size num3 can take is what? 255. Now you can point into your calculator to calculate 2 raised to power 8 minus 1, which is 225. Now, what if we put a value that is higher than 225 into it? What happens? Let's say we put this into it and we save it. What happens? We have a compiler error. Can you see? What is the compiler error? The compiler error means that we have a value that is higher than the memory size that was allocated to the value. So the variable can only take a memory size of bit 8. And bit 8, according to this calculation that I did here, is 2 raised to power 8 minus 1. Now let's say we even say 2 raised to power 56, 256. What happens? It's still a problem. It's still a problem. But if we put exactly 255, what happens? We still have a problem. It says it doesn't fit in the range of I8, which is range of 1 to 120, 127. So let's make our calculation. Is my calculation of 2 raised to power 8 minus 1 actually correct? To 255. So power 8 value, please. Minus 1. Larry, please.
Ayo, it should be right, but you need to split it in between. so that you have your negatives one side and your positives one side.
Oh,
So
sorry, I didn't put that. Thank you so much.
Mhm.
Thank you so much. Thank you so much. Thank you so much. So in this case, it should be this. It should be this. Thank you so much. So that actually left my mind. So now that comes to explain the difference between U8, that's unsigned integers, and signed integers. Now remember that we said the unsigned integers and signed integers, as long as the bit size is 8, it is 2 raised to power 25, 2 raised to power 55. Now the unbit, the signed integers, which is normal let me put this. Let's num4. Let's name it num4. I8 equals, now let's say 127. Now this is 127, the maximum size. Why? This is because 127, this can also be what? Let's name this num5. I8 can also be minus 127. So it's on the number line, it's because of the fact that it is integers. The difference between integers and unsigned integers is that integers start from the negative axis, and unsigned integers start from what? The positive only. So an unsigned integer like this U8, if we put minus in front of it, we have a problem. Can you see? But because it is a signed integer that starts from 0 to 255, which is 2 raised to power 8 minus 1 for the calculation of the bit, it can only take maximum of that. Now for the I8, which is signed integer, in this case, it is starting from the negative axis. The negative axis to the positive axis, which is minus 128 to 127. And if you are to do the addition, it's going to give us back what? 255, which is the maximum. So this one can also, so this is going lower. So from 1 to 7, yes. Backward, yes, this is correct. So from 1 to 7 back to the front. So 1 to 7 to 1 to minus 1 to 7, I mean, to 1 to 7. So I guess that basically explained that. Does everyone understand that, or is there a question based on what we've just explained on bits and bytes? Anyone has any question? Can we get thumbs up if everyone is good to go with no question? Okay, great, great. So our time is fast spent. In fact, we've gone past our time. We've gone past our time. So I'll stop sharing, and I promise that at the end of today, we are going to have access to our assessment again. So you should look forward to our assessment again, and everyone can basically take the assessment all over again. So at the end of today. So I'll stop the recording. Thank you very much, everyone. I appreciate the time you've spent to, come to class and to learn. And I hope everyone literally is going through everything that has been taught in class, repracticing, just like Edwin mentioned at the beginning that she practiced before joining the class. So please, everyone should also try to do that. If it is not even what you want to learn in the next class, what has been done in class, please try to just play around with it. There's some things that I did, you can just even go further and try different things. It's good. You can come to class with questions, and then we attack these questions together. We hear everybody's view on this question, and then we attack it together. So thank you once again. And I specifically appreciate